Okay, this is sample problem 10.1. Calculate the pressure exerted by a column of mercury 70.0 centimeters high. Express the pressure in pascals and in atmospheres. The density of mercury is 13.5951 grams per centimeter cube. So a column of mercury has a pressure which is proportional to the height of the mercury times the density of the mercury times the gravitational acceleration of the Earth. The issue here is the MKS system versus the CGS system. Chemists are all over the place when it comes to pretty much everything. Sometimes we use the MKS system, sometimes we use the CGS. So with this issue, what's happening is all of the units, or some of the units, are in CGS, some of them are in MKS. We're going to put them all into MKS. MKS is meters for length, kilograms for mass, and seconds for time. So the height is given as 70.0 centimeters. That's CGS. We're going to convert it to the MKS system, meters. So 1 meter is 100 centimeters. So that makes this 0.700 meters. The density is a little more complicated because the density, if I'm going to move all the way over here, the density is 13.5951 grams per centimeter cube. We want to convert that to kilograms. A kilogram is 1,000 grams. Okay, so you're dividing it by 1,000. So you get 0.0135951 kilogram per centimeter cube. However, a centimeter cubed is not MKS, that's CGS. So we need to convert centimeters cubed into meters cubed. So 0.013595 kilograms per centimeter cubed. We want the meters on the bottom. See how centimeters are on the bottom? So we want to have meters on the bottom. So a meter is 100 centimeters. However, it's not a meter, it's not a centimeter. It's a centimeter cubed. So we got to cube this. Now, when you take when you take 1,000 and you cube it, a 100 times 100 times 100, right? 100 centimeters cubed. That's 10 to the 6th, a million. Okay? So this is going to be times 10 to the 6th centimeters cubed per meter cubed. Now your centimeter cubed are gone. So if you take 0.013595, multiply that by a million, you get that the density is 13,595. I actually left off the 1 in a couple places. Kilograms per meter cubed. Okay? So now the density is in the MKS. G is already in MKS. G is 9.80655 meters per second squared. So we've already got that one. Okay? So we have everything in the MKS system, so now we can plug it in. P equals HDG. So that would be 0.70 meters times 13,595.1 kilograms per meter cubed times 9.80655 meters per second squared. Okay? Pressure, let's calculate that. 0.7 times 13,595.1 times 9.80655 equals 93,300. What are the units? This meter is going to cancel with one of those to make that a 2. This meter here is going to cancel with another one of the meters, so we just have meters on the bottom. So we have kilograms over meters times seconds squared. That's a Pascal. That is a Pascal. 1 Pascal is a kilogram per meter second squared. Now, the last part of this is to convert it into atmospheres. So here's the conversion factor. 1 standard atmosphere. Consult with your local meteorologist to find out how we define a standard atmosphere. The standard atmosphere is 101,325 pascals. What happens is the pascal is not a real practical unit because atmospheric pressure is 100,000 of them. So we're going to use this new unit here called the atmosphere. So we take 93,300 pascals, multiply that by 1 atmosphere per 101,325 pascal, and we're going to get a little bit under 1. So 9, you know what, I've actually got this original number, so let's leave that in there. Divide that by 101,325. And you get 0.921. A little over 9/10 of an atmosphere. Okay? Sea level, 1 atmosphere. 0.921 atmosphere, that's probably the typical pressure you would get due to the air at, I don't know, 2,000 feet or 3,000 feet or something like that. Okay, so there you go. We have it in pascals and we have it in atmospheres. That's sample problem 10.1.